Hello. Today, I want to show you what is the difference between observational versus experimental studies and which one we can rely on. So let's get started. Observational and experimental. And this is going to give us insight on how do we design our experiment or talk about validity of some results that we hear in the articles, news, and so forth. So I'm going here to compare two actual studies that is called Study 1, that is nurses' health study. So the study was run by Harvard and others, and it was about the effect of HRT, which is hormone replacement therapy, on coronary heart disease. So that's CHD. And so this study was run from 1976 till 1992, and the sample size was over 59,000 nurses. So this study was observational. It was based on a survey that was sent to married registered nurses that they were aged 30 to 55 years, and they mailed questionnaires to them. And then every 2 years, they would send follow-up questionnaire. So according to this study, which they also adjusted for various factors, they came to this conclusion that HRT reduces the risk of coronary heart disease. But it has so many problems. Let's compare it with a somehow equivalent purpose study that is experimental. Let's clean this part first. Now, our experimental study was, we call it the study of Women's Health Initiative. Women's Health Initiative. That was run from 1991 to 2002, and it was early ended at 2002. So you might guess probably why, but let's just talk a little bit about it. It was also run by Harvard and others, and the sample size was smaller. It was about 16,600 women. What was the method? It was a bit more randomized than what we heard about the other observation study one. It was randomized because women recruited by mailing campaigns. So the recruitment was by mailing campaign, and whoever consented to participate and met eligibility criteria. So they had consent and had eligibility criteria. Eligibility criteria. They were recruited. Now, in the method, we had more control. Some people randomly assigned HRT, hormone replacement therapy, and some randomly just placebo. After that, the analysis compared these two groups for CHD, coronary heart disease. And I said it was ended in 2022. That was an early end. And the result was that HRT statistically significantly increases the risk of CHD. So as you see, the results was completely opposite to the observational study. Now let's see which one we can really trust and what are the problems with each one. So in our study one, which was observational, first of all, it was not controlled. There was no placebo effect included as part of the study to see if the group that had the therapy did worse or better than the group that did not have. So it wasn't controlled. The sample size was good, but nurses are not really representative of the population. Nurses could be usually take better care of themselves. So it might have canceled out the effect of HRT. And so their coronary heart disease was reduced, no matter if they take HRT or not, just reduced because they overall take care of themselves better. It could be that. So this sample is not really representative of the population. Okay. So this is very important that our sample is a representative of the population that we are trying to understand pattern about them or explore pattern about them. One of other reason that was messing up with the results could be that it is self-reported. The self-reported studies are prone to bias. We may not really be clear or precise about our responses when we fill a survey. And so that cannot be totally relied on, especially when we have a sample that is not exactly from a diverse group of women. So that's the problem with study one. Now, study two, which was experimental, it is controlled. And so it's not self-reported. It takes into account, controls takes into account the placebo. So we can probably have a causal relation or make a causal relation between response and explanatory variables in an experimental study. In fact, when they were recruited women, they had to meet some eligibility criteria. So that would make the group less representative of population, I would say. So less representative because we are setting some limit here when we say certain eligibility criteria. So that's an issue in our second study. Because what if that certain eligibility criteria was the reason that was playing a role in our results, was the confounding factor? And so in general, what we can tell with this too, we can more rely on the study two results than the study one. Study one was observational. In an observational study, we cannot make a causal relation between our explanatory factors, and our response variable. So if this is our response variable and these are our explanatory variables, we wanted to see whether CHD gets increased by HRT and some confounding factors. Also, that's our explanatory variable, and that's our response variable. So I wanted to understand the effect of HRT on CHD. We cannot build a causal relation. Why an observational study? We say HRT reduces the risk of CHD, but could be just a correlation. We cannot exactly pinpoint that it is a cause. There could be other confounders playing role. However, in a study two or in an experimental studies, we can make a causal relation because we have controlled it for placebo effect. Now, the study two has its own problems, like what I said, the eligibility criteria which makes our sample less randomized, but it's better than study one. And the population that they have chosen, it's probably from different type of jobs or groups of women. So it's more representative rather than just taking nurses who are more health conscious. So to summarize this, we want to get some insight from data. We might use observational studies. People just report what they see, what they feel, and based on those results, we can have some insight. We can see the relations of different parameters. But if we want to build a causal relation and understand the cause based on data and a statistical analysis, then our study should be experimental. It has to take effect, the placebo effect, it has to be randomized, the sample has to be representative of the population. It should not have bias like self-reporting. And this way we can conclude better outcome, or we can build better relation between explanatory variable and our response variable. In the next video, I'm going to talk about causality and confounding, and how would confounding factors in these two studies can distort our conclusion.